I'm Dhanlakshmi from Shri Venkateshwara College of Engineering. Today I'll be discussing a topic on requirements modeling scenarios, which is a topic related to software engineering. Let's look what is there in this topic. Requirement analysis. So this results in the specification of software's operational characteristics, indicates software's interface with other system elements, and establishes constraints that software must meet. So the types of models we have is scenario-based models, data models, class-oriented models, flow-oriented models, and behavioral models. But I'll be mainly focusing on scenario-based models. What is requirements modeling? So this modeling uses a combination of text and diagrammatic forms to depict requirements in a way that is relatively easy to understand. So why is it so important? It's because to validate software requirements, you need to examine them from a number of different points of view. In this presentation, we'll consider requirements modeling from three different perspectives. So scenario-based models, data models, and class models. Each represents requirements in a different dimension, thereby increasing the probability that errors will be found, that inconsistency will surface, and that omissions will be uncovered. In requirements modeling, the primary focus is on what, not how. What users interaction occurs in a particular circumstance. What objects does this system manipulate? What functions must the system perform? What behaviors does the system exhibit? What interface are defined? And what constraints apply the requirements model must achieve. The three primary objectives are to describe what the customer requires, secondly, to establish a basis of for the creation of a software design. Thirdly, it is to define a set of requirements that can be validated once the software is built. The requirement modeling action results in one or more models, which are scenario-based models. So, scenario-based models are from the point of view, from the perspective of various system actors. Data models that depict information domain of the problem. Class-oriented models that represent object-oriented classes and the manner in which classes collaborate to achieve system requirements. Flow-oriented models that represent the functional elements of the system and how they transform data as it moves through the system. Behavior models that depict how the software behavior consequence of external events. In software engineering, scenario-based requirements modeling is a technique used to capture and analyze the functional requirements of a system through the use of detailed scenarios. Scenarios discuss specific instances of how users interact with the system to achieve their goals. This method helps to ensure that the system meets the needs of its users by considering different perspectives and use cases. So the key elements of scenario-based requirement modeling are actors. Actors are primary actors and secondary actors. So these are the entities like user systems or any external devices that that interact with the system. So those who interact with the system is called as actors. So it can be primary or secondary. Primary is like the direct users of this system. Secondary is the those who interact with the system indirectly. So goals, uh, the objectives or outcomes that actors want to achieve through their interactions with the system. Goals help to define the purpose and scope of the scenarios. Scenarios detailed narratives that describe specific sequences of interactions between actors and the system. Scenarios can be written in natural language or represented using diagrams. Use cases formal representations of scenarios that describe the steps taken by the actors to achieve a specific goal. Use case often include the success scenario and the alternative flows, exceptions or errors. The steps involved in scenario-based requirements modeling are identifying. Firstly, you need to identify the actors and goals. Determine who will interact with the system and what they aim to achieve. This helps to define the scope and context of the scenarios. So, and then develop scenarios, write detailed narratives for each identified goal, describing the sequence of interactions between the actors and the system. Consider both normal and exceptional cases. Create use cases. Formalize the scenarios into use cases, specifying the main success scenario and any alternative flows. Use cases provide a structured format for capturing requirements. Next, what you do is validate scenarios and use cases. Review these scenarios and use cases with the stakeholders to ensure they accurately reflect user needs and system behavior. Validate against business objectives and technical constraints. And refine and iterate. Continuously refine the scenarios and use cases based on feedback and evolving requirements. Iterate to ensure completeness and the accuracy. The requirement model acts as a bridge between the system and system description and the design model. Scenario based modeling, so although the success of a computer based system or product is measured in many ways, user satisfaction resides at the top of the list. If you understand how end users and other actors want to interact with the system, your software team will be better able to properly categorize requirements and build meaningful analysis and design models. Here, requirements modeling with UML begins with the creation of scenarios in the form of use cases activity diagrams. So firstly, you will create a preliminary use case like what to, we need to know what to write about, how much to write about, how detailed to make your description, how to organize the description. Then, for example, you can take, firstly you need to identify the actors. Like if you consider like a CCTV camera is placed in your home, so the who gets benefit is homeowner. So he acts as a primary actor here. So he'll be able to view the camera. So he can view it in his PC, and it can selectively record camera output and replay the camera output, access the camera surveillance via the internet also. These are the other activities or things which can be done by the owner. Then what you do is write a formal use case. The informal use cases presented in the previous section are sometimes sufficient for requirements modeling. However, when a use case involves a critical activity or describes a complex set of steps with a significant number of exceptions, a more formal approach may be desirable. In many cases, there is no need to create a graphical representation of a usage scenario. However, a diagrammatic representation can facilitate understanding, particularly when the scenario is complex. For example, we had taken CCTV surveillance in a home. So there is a homeowner who acts as a primary actor here. So he'll be able to access camera surveillance via the internet and also configure safe home system parameters and also set alarm if in case there is any threat, and the access camera surveillance via the internet is connected to cameras. It's instead of writing the description, if we do diagrammatic representation, it will be much easier to understand also. That's why we'll be using this. Like any other form of written description, a use case is only as good as its authors. If the description is unclear, the use case can be misleading or ambiguous. A use case focuses on functional and behavior requirements. However, scenario-based modeling is appropriate for a significant majority of all situations that you will encounter as a software engineer. If developed properly, the use case can now provide substantial benefit as a modeling tool. That's it about this concept. Thank you for watching this video.